Today we're going to talk about testing, and specifically we're going to go over some examples. We're going to show you a testing library for React, and then also a end-to-end testing tool called Playwright. Um, but before we dive into actually the examples, I just want to go through to kind of set the background, set the stage with a few concepts around testing that you may not be aware of. So the first question to always ask is why should you test? And there are actually quite a few reasons. The most obvious one we think about is we want to guarantee that the business logic that we've written is correct. So we write tests around functions, for example, to make sure that given a set of inputs, that we have a consistent set of outputs from those functions. But we also need to make sure that application features work well together. And that's necessary because in today's development environment, almost every application is developed by a team, every major application. And this will certainly be the case at companies you work at. So because different developers are developing different parts of the application, before you promote new releases to production, you need to make sure that everything works well together. Because it's very possible that I could do a local test on my PC and everything works. But once we merge my changes with Dinesh's changes, with Katerina's changes, that we may find some discrepancies or some differences. We also need to make sure and constantly check that the application is user-friendly and that it's following the UI UX guidelines and standards the team is set up. And this is one reason for Voyages. For Voyage teams that have a UI UX designer, kind of something that's related is I always suggest that once they create the wireframe, don't exit the project. Still attend the meetings, still participate in the Scrum events, because I think it's important for a UI UX designer to continually review what the developers have created to make sure that it matches the design that they came up with. The other side of that is that developers may run into problems or have questions when they're implementing a UI UX design. So it's really handy for the UI UX designer to be available to help answer those questions. Again, that's a little bit off topic. In terms of testing, it's good to test the UI UX as well, or to use testing to check out the UI UX. You also want to make sure your application is accessible, and your team should have agreed on some type of accessibility standards or guidelines to follow. And that's very important. In this case, accessibility refers to the application's ability to be usable by users who have some type of impairment or disability, like color blindness, for example. You know, you may not know this, but there are multiple forms of color blindness. Very few people have total color blindness, where they can only see in shades of gray or black and white. But actually, across the Earth, 14% of the Earth's population suffers from some form of color blindness. So that could be red color blindness or green color blindness, or again, there's all sorts of variations of this. But in order to make your application accessible, to everyone, it's important for it to understand, or for you to understand, how to implement it for certain common types of again, impairments like color blindness. Another example of that I've seen is people that are deaf or have a hearing problem. some applications will sound an audible tone or a sound whenever a mistake is made, like a data entry error. But for someone who's deaf, they're not going to be able to hear that sound. So something I've seen done in the past is for an application to not only play a sound, but also have some type of visual clue that displays on the screen to let the user know, what field was entered in error. Yeah, and let's see who posted this. Someone had said even in solo projects that's also a must in terms of just testing, because you're right, you never know what errors are introduced. Another part of making your application available to a wider audience is you want it to be responsive. And if you're not familiar with what responsiveness is, it's basically the application's ability to be able to run on, multiple different types of screen sizes. Everything from a phone to a tablet to a laptop to a widescreen monitor. And it's not just that the screen is visible, it's that it's laid out in a way that makes sense for that particular device. And more importantly, for the constraints of that particular device. A good example is if I'm running an app on a widescreen monitor, I've got enough screen space for basically lots of different things on a given screen. But if you're running from a phone, your display space is very small. So there may be some things when you're running on a phone that aren't displayed unless you specifically select them. Whereas if you're running that same app on a larger monitor, that everything is displayed on a single screen. And again, this is one of the reasons this is important, as everybody here knows, we live on our telephones these days, our mobile phones. So that's why it's good to make your app responsive so you can reach a wider group of people. You also want to make sure your application performs well. There are a lot of studies that have been done over the years about what's the best response time, or what is the minimum response time that you should shoot for. And they all average out to something that says if from the time the user hits or creates some event, whether it be like pressing the enter key or clicking on the mouse, your application should refresh the screen within 3 seconds. Now, if you're writing a corporate application for corporate users, performance is most definitely important, because you want satisfied users and you want them to be productive. You don't want to waste their time. But this is even more important if you have a general purpose web application or website, because there's a lot of studies that show that when you reach that 3 second spot, and some of them even are lower, there's some that say 1.5 seconds, but when a user has to wait more than 3 seconds, they'll abandon the site. They'll leave the site and go someplace else. So performance is one way of really impacting your retention of users. It should go without saying in this day and age that security and privacy are really important. So one of the things that, especially in larger corporations, but certainly we should all pay attention to, is testing to ensure that our application can't be hacked, or at least can't be easily hacked. Now, I used to work in information security, and specifically in network security, and we implemented a lot of different devices and software tools and strategies that protected our network. So, we made it as hard as possible for anyone who was unauthorized, like a hacker, to enter our network. But ultimately, your best protection, it is not a router or a firewall or anything like that. Your best protection and your last line of defense is the application itself. Because if a hacker should breach your network and get access, you don't want them to have uncontrolled access to your data and your applications. And I'll tell you that I can speak to Bayer. I left Bayer in 2018, but their information security department, they had an entire group set up that did nothing but tested applications. So they were divided. They had one information security group around governance and compliance. They had another one about threat response, so that when there was something detected like a hack, they would respond to it as fast as possible. But then there was a third group that was focused on, how do we ensure that our applications are secure? There's also edge cases. Many times we write, or when we sit down to write a test, we write them against the specifications and requirements that we built or that the users gave us at the beginning of the project. But throughout the life of the project, you're going to discover edge cases, things like where a user will be testing in like a end of sprint user review. They'll test some functionality, and then you'll find out some additional details about what they actually need, or maybe what a specific group of users need out of this particular feature or this particular screen. Well, that's really an edge case. It's something that the mainstream users don't necessarily need, and maybe don't need to know about, but maybe there's some type of manager approval process, for example, that they didn't identify when the project started. Well, when you discover that becomes an edge case. So as you discover those, you need to make sure they're tested, because ultimately they become part of the functionality of the application. And then when bugs do occur and you fix them, when you have later releases of the application, you make changes later on, you want to make sure that you don't open that bug back up. That's called regression testing. So you want tests around at least the major bugs that you've corrected, to make sure that in 2 years' time or 3 years' time or 2 weeks' time, that they don't come back into the application because of some later change. And the whole point of testing is you want to balance, you want to maximize your user satisfaction by ensuring that the application does what the user needs and it does it well. So that impacts their satisfaction. But at the same time, you want to minimize developer time. And if you're doing manual testing, that's going to take more time than implementing automated tests, which we're going to show you quite a few examples of later on. So any questions about the whys behind testing? Okay, if anything comes up, feel free to ask. That's why we're here. All right, so I'm not going to go through all of these in detail, but many times we take a very simple view of what are the types of tests. We think about primarily about testing the correctness of the business logic. So we think about this in terms of these are unit tests. And sometimes they're called functionality testing. But these are the first tests we do. As developers, we write code, and then we create unit tests that validate, is our code correct? And once that's done, then we share our code with the rest of the team. We push our branch up to GitHub or GitLab or whatever repository management system you're using, and we merge it into a common branch so the rest of the team can see it. But that's not the only testing. Once you merge your changes into a common branch, like the development branch in the Chingu Voyage, you need to test again, because there's no guarantee that Andre's changes and my changes will work together. we would both have done our unit testing on our local PC and had successful tests. But that doesn't mean that when we start merging all of these different changes together in development, that those same tests still work. So this type of testing is called integration testing. It's basically you're testing to make sure all the parts work together regardless of who wrote that part of the application. And then I'm just going to, in the interest of time, you're probably aware of some of these, but as the size of your organization grows, you will find that you'll have entire suites of tests around things like UI, UX, and accessibility and responsiveness and so on. Now, another one that I always suggest in a voyage, or actually a project of any size, is once you've completed integration testing, once you're ready to release your product, it's not a bad idea to try to do one more test that is in an environment that's as close as possible to production. So it may be a branch in between development and main. Or at the very least, if you PR and you do your PR from development to the main branch, use the facilities in your whatever hosting service you're using, like a Railway or a Netlify or Vercel. They actually, before you do the merge, they will create a test environment for you that looks like the environment that's based off of the main branch. So they give you a way to do this production-like testing before you actually hit the merge button. Now, one other point, and we touched on it in the last slide, but I'm a big believer that I like to keep track of bugs. I like to use a bug tracking system or like an issue tracking system. And when a major bug occurs, after I fix it, I like to write a test for it. And I like to include that test in my in my testing suite. And that way, whenever we release new software as part of our release process, this is called CI/CD, or continuous integration, continuous deployment. It runs all of the tests in those test suites. And if any one of those tests fails, it basically prevents you from merging the changes into the production branch. In the case of a Chingu Voyage, that's the main branch. But again, this type of regression testing, it just ensures that the bug you fix today won't be reintroduced into the application, in the future. And again, the whole point of this is because there are different reasons for testing. That means there are different strategies and different types of tests as well. So a good example is this correctness. I may write tests around a function that computes, the new current customer balance. So the input to this function might be the current charges or the new purchases by a customer. The function would interrogate the database or whatever data source you have to determine what is the current customer balance, and then it would increment or it would add the new charges to the current balance to come up with a new balance. In other words, what is it that the customer owes us right now? So I would write a test that exercises that function, with different types of expenses, different situations, maybe passing bad data to it also to make sure that it issues the right error message. So that's one testing strategy. When you come down to to test performance, one of the things you may want to do in your tests is to measure the time from the time the there's a simulated press of the enter key until the time that the screen is refreshed. And if it's over a certain threshold, whether that be a second and a half or 3 seconds or 10 seconds, it doesn't really matter. It's based on your needs. If the response time is greater than that, then you would, the test would fail, and then you would look at that function or that bit of code to determine, how do we make it run faster? And then privacy and security, an example there for privacy is you're looking for data leakage. For example, it could be that in your application, only an administrator, like an application administrator, like a manager in the user group, user department, could see customer identifying information, like their phone number or their email address or whatever. Well, you would want to write a test to make sure that if I'm logged on as a normal user, I don't see that data. That would be an example of a different testing strategy. So any questions or comments or criticisms, they're all welcome. Okay, let's move on. All right, so where should we test? So for these different types of tests, and this is a very simplistic view, I'll warn you or let you know there are a lot of different very custom test sites and testing tools available. What I've identified here are just the most basic tools because that's what you'll have available to you in a voyage typically. But for functionality or unit testing, you're going to do that in your local on your local PC, your local development environment. It's going to be run against your working branch. That's where you're going to test. Now, when you get to things like integration and usability testing, really any of these other tests, you're going to run those against your development branch. And then for certain types of tests, like accessibility or this should actually say responsiveness, you can use DevTools and also Google Lighthouse. And Lighthouse is a tool that's built into the developer tool part of your browser, and it has some very specific tests around SEO and performance and accessibility and whatnot. So any questions? And for those of you, if you haven't seen those tools before, at least on a Mac, if you hit the Control, Option, and I, that will bring up additional tools you can use. So I have Lighthouse specified or selected here, and you can see you can run tests against mobile or desktop. It'll simulate the execution of the application on mobile or desktop. Pardon me. And then you can select specific tests that you want to run. Now, one caution about Lighthouse, it's a good tool. It's a very useful tool, but it's built upon, like averages. It is very possible that it would flag something as being a potential performance problem, but in your application, it's really not. So this is something you have to evaluate the recommendations produced by Lighthouse and basically analyze them to determine if it's something that you need to really be concerned about. So any questions? We'll make this one go away. Cool. Yeah, and again, there are so many different tools out there. It's really very easy to get distracted and quite frankly to waste a lot of time looking at all these different tools. I think it's a better approach when you're looking for tools for any reason is to first think about what it is that you need to do and identify what are the gaps in the basic tools that you have available or the tools that you already use. And then look for tools, specific tools that fill those gaps. One of the things I don't recommend that people do is to throw away your entire tech stack on every project. What you want to do is from project to project, I think it makes more sense to potentially add a few things to your tech stack, but do it based on that type of analysis. Don't throw everything away on every project. All right, but this can get complicated. And the thing that can complicate it is basically your relationship between the branches in your repo and your deployments. So this diagram shows the most basic development environment and basically production environment. These prod deploy and dev deploy, these represent the web hosts that you actually deploy to, your application to, and what branch they're based on. So in a voyage is a good example. If I'm working on a particular feature, once I've completed my unit testing, I'll push that branch up to GitHub. I'll create a PR to merge it into development. Someone on the team will review it. We'll run whatever tests we have against it to make sure, like integration tests, to make sure that my changes work with everyone else's changes. But where we'll test that will be actually on the development deployment that's out on the internet. And when we're ready, then we'll do a PR from development to main, and we'll do a similar deployment out to our production web host. Now, that's pretty simple. This is actually the most basic Git and GitHub workflow that you'll find. And this is the one that most companies base their workflows off of this. However, what you can see, or where you can get to, especially in a larger company or even a medium-sized company, is in between development and main, there may be other branches that specific teams other than yours use to run their tests. So while you have the privilege and the responsibility to merge changes into development, once you've completed your integration testing, your next step isn't the main branch. Your next step is to hand it off to the security team to test in their branch, or the QA team to do testing in their branch. Or another example, I worked at a company where our application was used globally. So we had teams that tested the application, basically the localization, the language translation, to make sure that the application rendered properly in Italian and Chinese and Finnish and whatever language around the world. So they had actually multiple branches that they used for that testing. And again, each of these branches ideally are deployed to the internet so those teams can test in an environment that's very similar to where your production is deployed. The worst case, I worked at a company, we had 7 or 8 branches, including main and development. So it was a really complex environment, overly complex. It didn't need to be that way, I don't think. Sometimes you see branches introduced because of politics. A team thinks that they need their own branch when maybe they really don't. So any questions? Okay. So again, the whole point of this is you really want to, best practice is to take a look at what are your needs? What are your needs and requirements and your constraints around testing, and make sure that you have an environment that meets those needs, but is still as simple as possible. All right, so let's let's dive down. We're going to get into examples, code examples in just a minute, but let's just go a quick overview of testing tools that are available. So the two that we're going to show examples for today is we're going to show you Testing Library, and specifically the React version of this, and then also Playwright. So Testing Library is more of a framework, and it's kind of a lighter framework, whereas Playwright actually simulates user activity, so you can do what are called end-to-end tests. And I'll show you some examples of this from an app I wrote where it actually tests specific user interaction with the application from the time the user started to use the app until they stopped for each functional stream. But there are others you may have heard of. Jest is kind of analogous to vtest and Testing Library. It's not as complex as Cypress or Playwright. Cypress and Playwright are both, again, these end-to-end test tools, whereas Jest and vtest and vtest and Testing Library, personally, I think they do they're stronger for unit tests and basic functionality tests. But then there are other tools. There's Chai, which is an assertion library. It can sit on top some of these tools, and it gives you a really rich set of functions to define, things like, I expect this result, and for you to determine what happens when I don't get this result. Sign-on is specifically around user authentication. And then Istanbul, I don't see this used a lot anymore. It provides test coverage reports. It's very helpful because it looks at the tests that you've run, and it gives you a rating, a percentage, and it says, oh, well, your test suite exercised 50% of the code paths in the app. I'm going to get to you in 1 second, Nika. One note here is I've seen companies and even processes like test-driven development that say, before we can go to production, we need 100% test coverage. And I just think that is, I think personally, I don't think that's the best practice, because to get 100% test coverage, it takes, literally, it could take 3 or 4 times the amount of time to get there than it took to write the application. And with every change, that coverage could decrease from 100%. I think a better, a more rational, and a more practical approach is to achieve 100% testing for key functions and key functionality in your application. That those functions that the app has to have, it has to do really well. But then over time, with each release, keep adding to your testing library. I think that makes more sense. I used to say, oh, well, I think getting to 70% or 90% test coverage is good. And that certainly is good, but I don't think it's appropriate to target for a particular percentage. I think you have to look at, again, what are these critical bits of functionality in your app, and make sure they're tested first, and then start adding tests for other parts of the application over time. So yeah, Nika, I'm sorry, let's get to your question.
Thank you. I was wondering, so I see that some tools that you listed are frameworks, some are runner and plugin, and I was just wondering, what's the significance between a runner and a framework?
That's a good question, and that takes us to the next slide. So,
thank you.
Great. Did we plan this? So, like a test runner, it's software that typically it plugs into these frameworks, and it helps control the sequencing of the tests. We'll see in a Playwright example in a minute that you can tell it run the tests serially, run them or synchronously. Test 1 has to complete before test 2 starts, and so on. Or you can tell it just run all of the tests at once, and it'll do that. The frameworks are more general packages, like Jest and Cypress and Playwright. It's a more fully functional testing environment or test software that does a little bit of everything. Now, what we used to see, or what I used to see a lot of emphasis on test runners and assertion libraries and so on. What I'm seeing over the past 5 years for sure is most of the frameworks are adding this functionality in. And so, at least for me, for my needs, every need I've had in an application for the past certainly 3 or 4 years, I use Playwright, and it does everything that I need. So there's less emphasis, I think, on having a separate assertion library and a separate coverage tool and whatnot. So that was a good question. And this is a kind of a fuzzy area. When I built this slide, it's been about a year or two since I built it, but I remember that I found different definitions for each of these, depending on where I looked. So it's a little fuzzy and a little frustrating. Yeah, Andres, go ahead.
Yes, Jim. So assertion libraries are not only used on tests. I've seen the use of assertion libraries within your code to assert that some values are correct and throw an exception if they are not. So I've seen that that's not necessarily part of a test, but part of your code, the assertion libraries.
Yeah, that's a good point, and I forgot about that. That you can use assertion libraries to do what's called defensive coding. So you could use them, for example, at the beginning of a function to make sure that the parameters that are parameter values that are coming into that function are the correct data types, the correct ranges, and whatnot. And that may or may not be as important if you're using a strongly typed language, but it's certainly useful because even typing's not going to tell you anything about ranges, or it's not going to necessarily validate numerical ranges, for example. Or even, a case in point, I've seen some applications that different parameters, the values of the parameters are kind of a mix of alphabetic letters, and numerics. So it's sometimes difficult to do a simple range check. And that's where an assertion library might help. Yeah, so what does a test look like? Let's dive down into some actual code. So this is a Playwright test, but the parts of this there are 3 parts of this that are common to just about every one of these frameworks, whether it be Cypress or Jest or whatever. So the first part is this test describe. This basically is a wrapper that collects together one or more tests that have the same kind of purpose, or they're in the same category. So again, we might have test describe, testing a particular bit of functionality, and then we would have these multiple test sections underneath or within the describe that test specific situations. Now, one nice thing is, like for the describe and for the test itself, when you run the test, frameworks will give you a report, and they will echo out this text that you provide. So it makes it a little easier to see, if something passed or it failed, exactly what was it that passed or failed. And again, just a little kind of, I think it's a best practice. Something I found useful is I like to have a unique prefix, a numerical, like a 4-digit prefix on my describes and my individual tests. So my describes might be, 0, 1, and my test might be 01.000 or 0001 for a specific test. And what that does is that helps with the sequencing of the tests, but it also, if something goes wrong, it tells you exactly, you've got that identifier to be able to tie it back to a specific test. And you might even have documentation built around that identifier, to tell you, what is this test doing? What's the objective? What things have we seen work and fail in the past? Because essentially your test is a code. All right, so the first part, or the next part here, this before all, there are different syntax used across different frameworks, but for Playwright, or for all of them, I should say, they support some type of code or segmentation of code that's run before the test is run. So what this one does is actually launching the browser. But before all might do something like it might create a small database from a set of what we call golden test data. It may create and load that database to set up the test environment. See, driven tests like Go promotes, and I bill my, oh yeah, you bill your tests the same way, yeah. And then after all, it's logic that's executed once the test is completed. So in this case, it's just closing the browser. But what it could do, let's say that my before all created a mock database. This test after might destroy that mock database. It might delete it if the test failed. Obviously, if the test worked, I'm sorry. If the test failed, you might want to retain that database because it may have some useful debugging information for you. And then finally, the test itself, this is a specific test. In this case, we're just testing to make sure that the landing page has a heading that contains this exact text. So it's a pretty simple test. And this is an example of a type of assertion. We're expecting that this title that we're looking for on the page is defined. In Playwright, if this locator function, if it didn't find a heading with this text, it would return undefined and assign it to the title variable or the title constant. So if title is undefined, then this test would fail. So any questions? Okay, let's do something more fun. Let's dive into some specific examples. So both of these, this slide deck is actually in the Town Hall chat channel, and these are two repos that are in the Chingu Voyages, organization in GitHub. They're public repos. But let's actually look at the real code and we'll run it. So the first repo is Roundtable React Jest, which is misnamed because it's what it's actually, it's the React Testing Library. I apologize. In the original version of this presentation I did a year or two ago, we were using Jest, and I've converted to React Testing Library because just me, I think Testing Library is a better testing framework. So let's see, I want to check messages or the chat real quick to make sure I didn't miss anything. Okay, I have it. All right, so the first thing is in my setup, I've created a specific folder in the source directory for my tests. And I have 2 tests here. Depending on the size of your application, you might have one folder or one directory and all your tests in one directory. But it is possible to have subdirectories so that you might have your tests broken out by specific functions. It just makes it easier to find, the specific test for a specific function. And then in my package.json, I've got a test command set up that obviously it will run the test. So let's actually run the application without a test just to see what the screen looks like. So we'll do npm run start. And this is a React 18 application that's using Vite. You'll see it's a really simple, ridiculously simple application. And this should be familiar because we use this in some of our other roundtables, this example, but this is just a temperature converter. If I type in Celsius 0 and I hit the convert button, it comes up with an answer of 32 for Fahrenheit. And if I reset it and I say enter Fahrenheit 32, it should say Celsius 0, and it does. Or if I reset it and I say Celsius 17, convert, that's going to be essentially Fahrenheit 63 degrees. So that's the application. It's pretty basic. So let's go back to Visual Studio Code and we'll stop the server and let's run the test. npm run test. Is this large enough? Can everyone read my screen, my Visual Studio Code? Or I should say, let me know if you can't, and I'll make it larger. So what this did, we ran the test command, and we'll go in and I'll show you what the tests are doing next. But this is basically the log of showing the results of the tests. We have 2 tests. One checks for the title, and it passed. And I'll show you the console. I like to put a console log in my tests to echo some of the values so that I could just see, for sure what came in and what came out. In the first test, we actually did a conversion check. The test provided Celsius 0, and it simulated the hit of the convert button to see the output was 32. And I could rerun this. That's what these options give us the option to do. But let's look at the tests. So check title. Again, it's really simple. It's just looking at that landing page. Well, first of all, it starts the application. It renders it. Then it gets any element, any literal element in the DOM that is temperature converter, and it assigns it to this constant title element. And then it has this assertion, expect the title element to be in the document. And if that passes, then this console log is issued. And that's what we're seeing right here. If it doesn't pass, if the test failed, then this console log wouldn't be executed. Execution would stop at statement 7. So let's modify this and let's rerun that test. And we're going to test the test to make sure this fails now. And we can see it did. That the title is incorrect. We were expecting, I wish that would pop up like that. We were expecting temperature converter X, but that's not in this landing page. And again, it tells us that it failed. It gives us, this little summary. So any questions on this one? Let's look at something that's a little more fun to look at, a little more relevant. So the next test is checking that Celsius to Fahrenheit conversion. So it's a little more complicated. What it's doing is it starts by, again, starting up the application, it renders it, and then it's grabbing the reference to the Celsius temperature and the Fahrenheit temperature input fields, and then it's grabbing the reference to the convert button. And then finally, on line 13, what it's doing, this is simulating the user. Oh, could be bigger. I'm sorry, Andres. Let me increase this. Hopefully that's better. And then line 13, it's creating a new user event that essentially it's typing a 0 into the Celsius input field. And then it simulates, it does the click of the convert button. And then once the conversion is completed, it looks at the DOM again to verify that, it's expecting that the Celsius input field is going to have a value of 0 and the Fahrenheit field will have a value of 32. And then again, as we did in the earlier test, I like to throw in a console log that shows me the values. So and we can see this one worked because if we look at this check Celsius to Fahrenheit, we can see that, yes, it did, the test passed, and these were the input and the output variables or values. So let's make this one fail again. Let's change the Celsius value to 5 and the Fahrenheit value to be 32. Now, I think this console log is probably misplaced. I think what we want is actually show, we want to do a console log. We want to check that Celsius value, input value, before we actually do an expect. And I'm going to put this above the expect. Actually, I'm going to put it right here. So this test should fail. And actually, I didn't need to do that because the expect tells me the value that was received and the value that was expected. Oh, and I did this incorrectly. So we'll see if this works any better. So yeah, we can see the Celsius input was 0. Again, I didn't really have to do that because when it fails, it tells me the values. All right, so that's essentially React Testing Library. or a quick example. And again, what I like to do in terms of the process I follow is when I'm working on a function, let's say it's a new function, I write the code and then I write the tests. That's just me. If you're following test-driven development, you would write the tests first. But I've never found, again, this is my personal opinion, if you're using test-driven development, by all means, don't change because of me. But I've just found that in writing code, there are often many changes that occur between the time I start writing it and I'm ready to run testing. So if I write my tests first and then I write the code, I spend a lot of time updating the tests. So I like to do the code first. Now the danger in that is that you become so acquainted with the code that you write tests for what are called the happy path. The happy path is the path that always works. You want to make sure that you have tests that test what happens when I pass bad data, for example. So we might modify this test, for example. Let's just see what happens. Let's say that we input an alphabetic character. So let's save this and see how it runs. Yeah, so it failed because of the expect, but actually in the code itself, I should have had some validation of the input, which I don't have in this code. If we look at the app, it's just really very, very simplistic. So this convert temperature function that does the conversion, it's checking to see if the value has been specified or not, but it's not checking. Oh, it is checking if it's numeric, sorry. So why did that pass? That should have failed. I have to look at that. I don't know why that didn't work. We should have gotten, see, that's an example of why to test for bad data. This is showing that this logic there's a problem in this logic. It's probably converting that A to a numeric or something, who knows. All right, any questions on testing library? Okay, let's look now at Playwright. So Playwright is more advanced than React Testing Library. Playwright and Cypress, you could think of them as kind of being competitors. They're both end-to-end testing tools. Playwright is newer. I think Playwright's API is much stronger than Cypress. And some of that is just because Cypress is a relatively old tool. If I remember correctly, I think it was created back in the early 2000s for Java, and it's grown and expanded since then. And I may be wrong on that. I think I remember it from my Java days. And again, there's nothing wrong with Cypress. If you're using Cypress, don't stop using it. It's a perfectly good package, and it has a lot of functionality. This is one of those things that's just a preference. So the first thing I want to show you is Playwright has a configuration file. And so one of the things I've told it is where to look for the tests. And then there is this fully parallel. If I have this set at true, if I set this to false, it would run the test synchronously rather than asynchronously. So we can check that out in a minute. But it's got a lot of different options you could run. You can even specify what browsers do you want it to run on. Because that's something that's important for testing too. You shouldn't, or for applications, you shouldn't assume that your end users are going to be all using the same browser, at least on the larger internet for a website. Now, if you're in a corporate environment, that could be different. Your corporation most likely will dictate what is the acceptable browser. All right, so, oh, and there's also these CI/CD options. Um, Basically, what this option does is it allows you to determine, actually it's up above as well, it allows you to determine if the test will run in what's called headless mode, or browser mode or headless mode. Now when we run it, we're going to run it in browser mode. So when we actually execute these tests, we'll see that a browser will pop up, and we'll have a screen that shows us the tests that are running and the results of the test. When you run in headless mode, you don't have a browser window. And that's useful for CI/CD pipelines because the tests can all run in unattended mode. And you can set it up in, for example, GitHub, so that when you create the PR, it will run the tests. So your approvers would actually see the results of the test before they start their review and approval process. And that's really, really helpful. Because, and I should just dive in on that one just real quickly. One of the problems with not having automated tests and not having a CI/CD pipeline is when you create a PR and you ask someone to review it, you're also asking them to test it on their own. And you may not have created like a testing checklist for them to follow. So the way they test it may be different from the way you test it. They may, on the plus side, they may test things that you didn't think about, but on the minus side, they may not test everything that needs to be tested. So that's one of the reasons that this continuous integration, continuous development process is extremely useful. All right, so let's actually run the test. If we look at package.json again, we've got a test command. This is the exact same application that we used in for the testing library a few minutes ago. So let's do an npm run test. And so what you'll see is, because we're not running in headless mode, it takes it a minute, but you'll see a Chrome browser pop up. So this is essentially a testing console that's displayed. And so it gives us a list of all of our tests. If I had multiple tests within these files, it would show the individual tests. And I could choose to run them all or run them individually. Let's run this one individually. Let's test the title. So it's running, and we'll get the results here in just a minute. Let me make this larger too so you can see it. All right, so this successfully ran because we've got the green check marks. And that's pretty much it. If we look at the console, we can see that it ran. So now let's run the other one. Let's run the actual conversion. This just verified that the title was on the landing page. Oh, I ran this. Darn it, I didn't mean to do that. I'm sorry. And you can see while the test is running, it shows you the little clock in the circle. And then when it's complete, it adds the check mark. So here we can see that the conversion passed. We successfully converted Celsius 0 to Celsius 32. So now what we could have done, rather than running these individually, we could have said run all the tests. So we could click that arrow. The tests are now running, but they're running in parallel to one another. And this may not be what you want. There may be some tests that need the output of prior tests as their input, or they may need the database to be in a specific state based upon the prior tests. So you may want to run them individually. And you can do that again manually, or in that config file, you can specify that you want things to run synchronously. And again, here's our two tests on the console. If we go back, we can see the details of each of the tests. So any questions? Another nice thing you may not have noticed, but it also gave us the time that it took to run the test. So we can see that when we ran all of the tests, this took 4.4 seconds. And in each individual part of this, it times that as well. So it makes it really easy to see, okay, where should we what should we pay attention to? In this case, it's these two options, filling in the data and hitting the convert button, that we really need to maybe pay some attention to that because they took a little time. Yeah, go ahead, Nika.
I have two questions actually. So the first question is, I was wondering, is a long running test an indication of a bad test? Like, are all tests supposed to be short?
Not necessarily. It really depends. In this case, because we're using an end-to-end test tool, we're actually simulating user input. It depends on the functionality. There may be some parts of the application that are intensive. Let's say that there's a function that we provide to a manager of an accounting system to scan all of the accounts and to validate them in some way. So that's something that that might take a few minutes or longer. It depends on how many accounts are in the database.
Okay.
But typically, that what you asked would be true. For most of the functionality, you do want it to be relatively quick. Now, one other thing to be aware of, this 4.4 seconds doesn't make my blood pressure rise too much, because there is some overhead introduced by the test itself, by the environment. So your tests, generally speaking, are going to take a little bit longer to run than what you would see in the native application. So if I'm shooting for 3 seconds response time, this isn't going to upset me too much. I can see, I can assume that again, some of this setup that's running, you can see it's taken 1.4 seconds, and the teardown is taking another half a second. So that's essentially that 1.4 seconds above the performance threshold we set, assuming we set it at 3.
Thank you for answering that one. And I also, back several months ago in the beginning of the year, I failed a Q&A interview. And my issue was that I could not target a button programmatically, because the way it was put, it was like a div inside a div inside a div inside a div. It was insane.
Right.
And so my point is, in real life, could I realistically go back to a developer and ask to put a data test ID or something?
You could. The other option you have, it depends on the tool you're using, but let's look at Playwright here.
It was Playwright.
It was, okay. So in Playwright, let's go to the application too. I actually set a placeholder on the input fields. And it was for that very reason, to make them easier to locate. In fact, I did a name and a placeholder. Um, because it gets really tedious if you're trying to navigate down through nested divs or any kind of nested element, to find something. Playwright, and this is true of Cypress and Jest and React Testing Tool, they also have some generic capability as well. So you could search on a particular piece of text. Now that may not work for an input field. For example, I've hit this myself. When I'm looking for an input field, if I try to search on inner Celsius, it returns the reference to the label, not the input. So I think there are some good practices you can follow in the way you code your HTML to make it easier for testing. But kind of to give a little longer answer for the case of the nested div, if the divs had bits of text associated with them, you could, in these testing tools, you could find the highest level div, and then you could navigate down, to subsequent divs. There are some tools you could do things like saying, find the div that has temperature converter in it, and then greater than div, greater than div, greater than input. So you're kind of assuming that there are 3 divs above, or that the input field is nested within 3 divs. And again, for obvious reasons, that's actually very brittle too, because all it takes is a change in the UI UX, and now, that test that maybe worked in the last release won't work in this one.
Thank you.
Oh, you're welcome. You're welcome. So real quick, let's look at what a more, and again, this is going to be in Playwright, but let's look at what a more extensive test looks like. If I can remember where I put it, here it is. So this was an application I wrote for my high school reunion. And basically, this application allowed classmates ahead of time or at the door, when an event occurred, they could register and pay for the event. So in this case, there was a Saturday event at the door. There were different options that made this complex. Let me scroll down to those. So you can see this single test had 231 lines in it. But one of the reasons is that the amount that you could pay or would have to pay depends on, did you sponsor another classmate? In other words, did I say that I'm going to pay for Andres attending? Or if I'm a veteran, if I served in the military, my admission was free. So basically these tests, as you can see, they tested different combinations of those options. So we had, test 8, test 7, test 6. These are essentially very similar, except for the options are different. And because the options are different on the validations, they had to validate that a different amount was being charged based upon these. So this test actually contained what amounted to functions in it, because everyone had to sign up and check out. We had to select the number of attendees. And again, were they a veteran? Were they sponsoring someone else? And did they pay at the door as opposed to paying online prior to the event? So this was a true end-to-end test, because what it did is it exercised the application from the starting point from the landing page, and it simulated all of the user interaction, selecting of buttons and whatnot and options and filling in forms to finally get to, okay, what is it that they owe us? Oh, I'm sorry, I missed some messages. Andre says, with Cypress, you can see what query will be target the element. Yeah, you can say, same thing in Playwright and some of the others. So again, this got to be complex. And actually, when I wrote these, this is the version of this that tested someone registering before the event online, which included sending them an email. At some point, I was testing the test as well. So any questions? Or this is actually, we're at the end. This is all that I had prepared for today. Yeah, you can see the selector. Just as you have selectors in CSS and in HTML, you have selectors in the tests too. In this case, I was looking for an element that had the payment receipt, an ID of payment receipt. So some gotchas in testing. We want to you want your test data. If you're testing like a full stack application where you have a database, you're going to want to create a database that is production-like. It's going to have a range of data and conditions that match what you would encounter in production. But you're always going to want to make that recreatable. So you want to make a script or whatever that will let you delete the test database, recreate it from scratch, and reload all of the data into it. Because over time, if you're testing against the test database, that data gets very corrupted. You'll be deleting rows, you'll be adding rows, you'll be updating rows. And as you're doing that, you're potentially eliminating test cases that you set up when you design that test database. So you will have points in your testing where you want to recreate the input data, not just from the screen, but in your persistent data, whether it be files or database. The other thing you want to watch out for, and this actually happened to me at a company, we had a payroll group, and this was probably 30 years ago, but we had a payroll group that they decided that the best way to test was to make an exact copy of production and test against that. The problem is they got into a demo of the application for executives, and one of the executives sat down at the terminal and typed in his user ID, and it popped up with not just his salary, but with all of his bonuses and all the perks, if you will, the additional things that he received because he was the chief financial officer. And some of those he considered to be sensitive and confidential. So that development team really quickly had to go anonymize the data. They had to come up with a way to create those same kind of situations, but to take the identities out and even change values for certain types of users. This executive got really upset because his data was in the test database, and any of the developers could see it then. So that's another something to watch out for. Yeah, that was super sensitive. Trying to think of other cases, or situations, but that's some of the big ones. So again, let's do kind of last call for a question about anything, whether it be the voyage or this topic or anything at all. Is there anything that anyone needs help with? Cool. All right. Well, I think what we'll do is we'll give you the rest of your Saturday back. Thank you for your questions. Thanks for participating with us today, joining us today. Thanks, Andres, and everyone else that had questions and feedback in the chat. I apologize, I didn't catch all of those at the time. When I made the screen larger, it made the chat window smaller or larger as well, so I couldn't see as much. I didn't see everything everyone was typing. But again, we will post the recording of this out on YouTube tomorrow, and we'll provide a link in the Pound Announcements channel in Discord. So thanks, everyone. Have a good weekend. Go get your rest and relaxation, and we'll see you at the next roundtable. Andres is going to take us through terminal tools and the ones that he finds most useful. So talk to y'all later. Bye-bye.
Bye. Thank you.
Thank you.
Thank you.